Okay, this is 2.2, number 9. A company's total cost in millions of dollars is given by C of T equals 120 minus 40t e to the negative t, where t is the time in years since the startup date. The graph of C of t is shown to the right. I chose to leave that off because it was unnecessary. Find each of the following. So let's start with A, our marginal cost. Well, we know that C of t is given to us as 120 minus 40 e to the negative t. So the marginal cost is the first derivative, which means the 120 as a constant goes away. We'll have the negative in front of the 40 times the derivative of e, which is negative 1, then times 40 e to the negative t. So that those two negatives do in fact give us the positive 40 e to the negative t that we need for part A. Now, moving to part B, it's simply asking us to replace t with 0. And so we're plugging into this. And so we'll have 40 e to the negative 0. We know that 0 doesn't have a sign, but we also know that anything to the 0 is 1. And so that's 40 times 1, or 40. And so that's where we get our 40 million per year. All right, moving on to C. We're going to replace this time with 4. If you hear that chomping, I'm afraid that's my bulldog, and trust me, we are better off letting her do that than attack me and the pen. So we're going to have 40 times e to the negative 4. And so we're going to carefully use our calculator to do this. And I want you to also notice that this is in millions of dollars, okay? And that in answer B, it was 40 million per year. But they don't do that here in C. So be careful here. This is kind of a trick. So we're going to type in 40 times e to the negative 4. And then you'll want to use your right arrow key before you hit enter. And when you do, you get 0.736 2, 5, 5, and the 5 continues. Now, we are talking in millions of dollars, which they did account for in B, but they did not account for in C. So we want to multiply this by 1 million. And when we do, we get 7, 3, 2, 6, 2, 5, point the 5, 5, 5, 5. But notice it wants us to round to the nearest thousand. So this is in our thousands place. Looking at the 6, that tells us it's going to be 733,000. And thus, we get our answer for C. So be careful with that, because they, in my opinion, that's kind of a trick that they're playing on you right there. All right, so let's move on to D. We want to find the limit as t approaches infinity of c of t, and the limit as as t approaches infinity of c prime of t. Okay, so first let's look at the limit as c of t of as t approaches infinity. Okay, so I'm going to rewrite it so that I'm looking at the limit of c of t as t approaches infinity of 120 minus 40, and instead of writing e to the negative t, I'm going to write it as e to the t in the denominator. Now think a little bit here. That e to the t is approaching infinity. The t is approaching infinity. The e to anything, whether it's infinity, whether it's 200, whether it's 4,000, e to it, as it approaches infinity, it's approaching the 0. So we are going, I'm not saying this very clearly, so let me start over. As e approaches infinity, it is going to become larger and larger and larger until it actually blows up that part. And so our answer is 120. And I'm sorry I threw that other little garbage in there. Sometimes I can't think. All right, so now let's look at the limit of the marginal cost as t approaches infinity. And so that's really the limit of 40 over e to the negative t as t approaches infinity. And so as that t approaches the and I should have put negative infinity here, my fault. As it's approaching that negative infinity, again, it's going to blow up and it's going to become 0. I hope that was helpful.